question here is, how would I write the converse of this? Here we have a conditional. If M is on segment AB and AM equals MB, then M is the midpoint of segment AB. Now, something we haven't talked a lot about that I want to spend just a second before I get the answer to that question. The way this is written here with no symbol over top of it, it means the distance from A to B. I'm sorry, A to M. And then it's going to equal the distance from M to B. So when you see a symbol over the top, like in this, it means segment. If you see a symbol over top, like this, it would mean line. But with no symbol over top, like in this case, it means distance. So the proper way of reading this would say, or I should say if I read the meaning of this, we read it properly, but if we read the meaning, it would say, if M is on segment AB and the distance from A to M is equal to the distance from M to B, then M is the midpoint of segment AB. Okay? That's how we would read the meaning of that. But we never read it that way. We just read it as AM equals MB. You have to understand then that that means distance. The length of those segments, in other words. Okay? So the question I asked originally was, what's the converse going to say? Jackson?
If M is the midpoint of AB, then M is on AB and M equals MB.
Okay, really good. Except when you read this, you can't ignore this symbol because it's saying segment. We need to identify the segment, okay? But otherwise, that's exactly right. He said, if M is on the midpoint of segment AB, then M is on segment AB and AM equals MB. That is the converse. Okay? That's the converse. So let's write that down for a second. I'll pause. All right. Now, a biconditional uses the words if and only if. Okay? A biconditional uses the words if and only if. Sometimes it's abbreviated IFF. The symbol for it would look like an equal sign with an arrow on both ends. We can write this statement now as a biconditional. Since both of those statements are true, the original conditional and the converse, then we can write it as a biconditional. And what I just said was, since both were true, and this next statement says, can only be used if the conditional and its converse are both true. So biconditional can only be used if the original conditional and the converse are both true. Let me pause while you finish that, and then we'll move on. So how we would read that then would say, and you could write it either way. Sometimes it sounds a lot better written one way versus the other. But because it's a biconditional, both directions were true. And so I wrote this as M is the midpoint of segment AB if and only if M is on segment AB and AM equals MB. Now we could have said M is on segment AB and AM equals MB if and only if M is the midpoint of segment AB. But usually, especially with something like this is the definition of midpoint. It sounds better. It sounds better to start out with the word that we're defining. We're talking about being a midpoint, so I'm going to put that in the first half. Okay?
I need Carmen for blood drive.
What's that?
Carmen.
Okay. I want you to try it with this one. If x is equal to 7, then 2x minus 1 equals 13. Try to write that as a biconditional. Jeffrey, what'd you write for this?
I don't get it. I didn't write it.
Dalton, what'd you write?
I put,
Quiet, please, so you can hear Dalton.
I put 2 times x minus 1 because x is equal to 7, so I just placed the x, I replaced the x and turned it into a 7.
They want us to write it as a biconditional, so we need to use this. Okay? What's the hypothesis of this statement?
X equals 7.
X equals 7. What's the conclusion?
2x minus 1 equals 13.
2x minus 1 is equal to 13. If we wrote the converse, it would say what?
If X
2x
equals
minus
Yeah, you're getting good at that. Now, as a biconditional, we just take those two statements and in the middle we place a what?
IFF.
If and
Only if.
only if. So we would say x equals 7 if and only if 2x minus 1 equals 13. Or we might say 2x minus 1 equals 13 if and only if x equals 7. So that's how we would write that. Now I'll finish these and post this to the internet as soon as you guys leave during my conference period. But tomorrow in class we'll finish the rest of our notes. There's three qualities of a good definition that we need to understand. The first one says use words that are easily understood or previously defined. The second one is it must be clearly and accurately stated. And the third one is it must be reversible. In other words, we must be able to write it as a biconditional in if and only if form. So those are the three things that we need to understand about what it takes to be a good definition. We can't be using words that are confusing or not previously defined. We can't be saying things that aren't clear or maybe they're inaccurate. And we can't be using definitions that can only go one direction. If it isn't reversible, then it is not a good definition. It would be only sometimes true, in other words, and that does not make a good definition.